Hello everyone. Our experiment for today is boost DC to DC, and it's a step up actually. And in our manual, it's experiment number 8, MOSFET boost chopper. Okay, this is the circuit right here. Actually, we have the switch, which is the MOSFET, and we have the coil, which is the smoothing inductor, and we have the power diode. Last time in Buck, it was the switch was right here, and the diode was right here, and the coil was right here. So it was, if you rotate it by like one step clockwise, that's what you will see. So that's the difference between the circuit of MOSFET and of boost and Buck. Let's see here. We're gonna follow this circuit right here. We start from the source. Should be DC, and the output should be DC. So the source. By the way, guys, here we notice that since this is a boost, make sure that your knob is 0 before you turn on, and the maximum that you give as a volt is 20%. So here it will be around like 25 to 30 volt. Source. Why is that? See, here we use two modules, two resistive modules, and each module is the rated value is 120 volts. So 120 volt plus 120 volt, that's 240. So 20% will give us like 25 volt, and the output will be around 250 volt, which is okay. But if I give it, for example, 120 as a source, and then my duty cycle is huge, then I can have like over 1000 volt, and this will damage my my MOSFET. So let's see here. We start from the source 7N to the inductive, which is smoothing inductive. Here it's connected in parallel this time, not like last time. Each coil here is 0.4, so 0.4 parallel with 0.4 is 0.2. Then I go out to AC emitter. So I have two AC emitters. One measures the inductor current, IL, which is this. This is the isolator. This is the current isolator right here. And the other one measures the current, which is the I out, that comes from the capacitor. We will see that. So we come here to we come to this. See here. We come to the inductive, and then we come to the AC emitter, and then to the current isolator, and then we come to our MOSFET. See here, we are using a MOSFET number 4. So we're gonna come to this MOSFET right here, okay, gate and drain and source, and then out. We close the circuit with the neutral right here, and then we will use diode number 1, and we will ground transistor number 1. This is grounded right here, ground transistor number 1. If I ground transistor number 4, then nothing will work. So we ground transistor 1 because we will be using diode number 1. Out from diode number 1 to this emitter. This emitter will measures the I out for me, and I out to the load. Both loads connected in series, and then from the load to the neutral to close the circuit. See here, we only use 400 in series with 400. We can use 400 from here and 400 from here, but we will not do that because we want more modules to have more rated value. Let's see here. Let me explain this point before I here what will happen actually. We have two cases. When we close the switch, the current will come from the source through the inductor, and it will come through the short circuit, through the switch. No current will go through the power diode, so no current this will be an open circuit. So the inductor is charging actually. In this case, when this is closed, this is charging. But we had voltage in the capacitor because it's parallel to the source, so we had voltage from before, from the previous process. When this is shorted, source current that goes through the inductor, IL, will go through the short circuit, but this capacitor will work as source for the load. So it will discharge. So the current here will decrease. We call it I out, will decrease when it goes to the load. So in same time, simultaneously, this is increasing, IL, but this is decreasing, I out. So this is increasing, this is decreasing. After that, when we open this switch, the current from the source will go through the diode to the load. Now, this is charged, so it will discharge. So IL will decrease, but I out will increase because I out is fed by the source. So put this in mind. Let's see here. Now that's what we have. I give it 20%. I have a voltage. I have around like output, which is 40 volt. Duty cycle is, let's say, 0. And my frequency is 0 right here. I think frequency is 0 right here. Okay. That's my frequency. And I will see when I give it some, when I increase the duty cycle, of course, since this is boost, even if there is no duty cycle, but I still have voltage in the output because this is step up. So if the source is 25, I have here 25, approximately the same. And then increasing the duty cycle, I will increase the voltage. See here? And we know the equation for the boost is V out DC equals V source divided by 1 minus duty cycle. We cannot have duty cycle equals to 1 because it will be 1 minus 1, the denominator will be 0. So V source divided by 0, it will be an infinity. But the maximum that we can get duty cycle, we know it's not linear because if it reaches close to 100%, there is a variation. Same thing when it reaches 0. See here? You can hear noise. Okay, see here? That's the maximum we can get. We don't want it to trip. But you can see here. Now, I will stop this. This is the current here. Which current is this? Is it I inductor or I out? The isolator is right here. So this is IL. This measurement is for IL. If I put the isolator right here, I will have current, but the opposite. When this is increasing, it will be decreasing for I out. It will be opposite than this. Look at the voltage, which is the blue, straight. Yeah, straight because of the capacitor right here. Last time we can have, without a capacitor, we will have it like on and off. We will have square wave. But since we have a capacitor, we'll make, but you can see that there is niche right here, up and down. Okay, if I decrease, look at the voltage. If I decrease the duty cycle, the voltage will decrease. See here? I stopped actually. See here? That's down. And when I increase, it goes up. See here? Okay. Okay, and that's the current and that's the voltage. That's boost actually. We'll go over this. And there's some questions right here. You can draw duty cycle 50%, duty cycle 75%, 25%. It doesn't matter. But this is the boost circuit and the boost chopper. And so let me just remind you about this point. Make sure, for example, this chart right here. It says 120, 220, 240. This is the system. So let's say we are working with 120 as a system. 120 volt. We're not going to work with 220 and we're not going to work with 240. We're working with 120. But it does not mean that your source, you will put your source 120. No. If you do that and you increase your duty cycle, you're going to burn your transistor, your MOSFET. So no, this is the system. I don't want you to increase more than 20% when you work with boost. Put this in mind. Even the questions, when it comes to the questions, here for example, this question on page 67 says a MOSFET boost chopper is powered by a 12 volt. So they give you a very small amount, because they want you to learn that you cannot have a huge source, because you're going to play with the duty cycle. If you play with the duty cycle, see here. So this is 0 duty cycle. That's my output voltage, which is around 40. But let me increase the duty cycle. See here. 100, okay, now 200, okay, now 250. That's with 20%. Imagine if I increase this. See what will happen. We're going to increase, okay, and we're going to bring this back. Okay, we know this before, that it should be in pulse width modulation. For, this is the technique that play with switch. And the same technique here, which is the volt, 2 volt, and 2.5. That's it. Make sure this is on. Make sure you give 24 volt for the chopper. Otherwise, you're not gonna see anything. That's it. This is mostly same as component, same as buck, but a different connection with the transistor and diode. Okay. Thank you.